Okay, I really love this problem. It is asking us about a lot of conceptual stuff. So, we're dealing with this winch that's pulling a boat into the dock. So, it's pulling the rope at a rate of 4 feet per second. So, that rate of change has to do with this line right here, because this is the winch getting pulled in at 4 feet per second. So, what we're going to do is, what do we want to call this? I don't know, it's the hypotenuse of the triangle. We have x squared plus y squared equals h squared. Let's just call it h. Okay, so this is h. We know that dh dt. We know that dh dt is equal to negative 4 feet per second. It's negative because it's getting pulled in, not let out. Okay, it's shortening, so it's negative. So we know dh dt is negative 4. Okay, we'll call this x. We know y. Y never changes. That's the 12 feet, right? That's where the winch is anchored to the dock. So this is 12. So what we want is how quickly the boat is moving. So we're looking for dx dt. That's this, right? Looking for dx dt. So what we have to do is we have to relate the three sides of the triangle using Pythagorean theorem. So we know that x squared plus 144 equals h squared. All right. So we need to implicitly differentiate this. So we get that 2x times dx dt plus 0, a derivative of a constant is 0. It's not changing, right? That 12 is stuck there. It's not moving, so the derivative is 0 because it's not changing. So then we get 2h dh dt. Okay? It tells us what h is. It says that h is 13 feet. That's what we're trying to figure out what the speed is at that point. So we have 2x dx dt. That's what we're looking for is dx dt. That's equal to 2 times 13 times negative 4. Because, again, dh dt is negative 4. That's given to us. Crap. Okay, we have two variables. We have x and we have dx dt. So we are in a little bit of trouble, but we know what h is right now. We didn't know what h is varying, but at this point h is 13. So we can solve for x. We say x squared plus 144 equals 13 squared, which is 169. So then x squared is going to be equal to 25. And x at this point only is 5. This is how far away the boat is from the dock when there's 13 feet of the rope left. Okay? So we plug in 5 for x. So we get 2 times 5 times dx dt. And then what's that equal to? 2 times 13 is 26. 26 times negative 4 is negative 108. So we have negative 108. And we're going to be dividing that by 10. So dx dt, we divide that by 10. We get negative 108 divided by 10, which is negative 10.8. So as the winch is pulling in the rope, and it's pulling it in at negative 4 feet per second, at the moment that the rope has 13 feet left, the boat is moving at negative 10.8 feet per second. Negative 10.8 feet per second. All right, for part B, it's saying how quickly, or what's happening to the speed of the boat as it gets closer to the dock. Well, what we should do for this is consider how changing the different variables affects our speed. So if we look at dx dt without fixing h and x, right, this is how we determine dx dt. It's how we did it over here. H was 13, right, and then x was 5, so then that's where our 2 times 5 came from, and our 2 times 13. So if we just look at this and figure what's happening as x and h change, well, first of all, we can cancel a 2. So again, we're just trying to figure out what's happening to dx dt as x gets smaller, right? As x gets closer to the dock, as the boat gets closer to the dock. So we get dx dt equals negative 4h over x. All right, so we're trying to determine what happens as x gets small, right? What happens as x gets smaller and smaller and smaller because, again, the boat is getting closer to the dock, and x represents the closeness to the dock, okay? Well, if we look at our triangle, when x gets small, h is only going to get H is only going to get really close to 12, right? Which is the height of the dock's like winch above where the boat is. So this H value is never going to become smaller than 12, right? So basically, what's going to happen is, if we want to draw the new triangle as the boat gets really close, we have our 12 feet right here. Okay, the winch is going to be pulling the rope like right there, and then there's the boat, right? If the boat is basically almost 0 feet away from the dock, then the rope is going to be almost the same length as this height. So basically, the rope is approaching 12. So the point is, as x gets really small, h is going to get close to 12. We're taking a negative number, and we're dividing it by something close to 0, which it means that the boat speed is going to get faster and faster and faster. It's going to move towards the dock faster and faster as that rope gets shorter. Again, because we're dividing by an increasingly small x value, and this is how we determine dx dt based on what h and x are. Okay, as x gets small, h is going to get close to 12. We're dividing a negative number by something really small, which is going to become bigger and bigger. The speed of the boat gets faster.